Good day everyone. Today I will be presenting my mobile application called Knife Detector. So the application was developed using Flutter for mobile development and TensorFlow Lite for on-device image classification. It allows users to scan knives using camera or gallery, view confidence scores, track scan history, and analyze results through a built-in analytics dashboard. Knife Detector supports 10 different knife classes. The app is composed of three main sections: scan. You can also view all identified classes. And when we tap or press the image, it shows the description of the class. Then we also have logs where we scan history where scan history is stored. Also we have analytics where scan data is summarized and visualized. So in the scan section, users can either capture an image in real time using the camera or upload an image from the gallery. Once an image is selected, the application pre-processes the image and passes it to the TensorFlow Lite model for classification. So the result display the predicted knife class, the confidence score, and a prediction breakdown showing how the model evaluated all possible classes. So during the testing, gallery images tend to produce higher accuracy compared to real-time camera scans. This happens because real-time images are affected by lighting, motion blur, and camera autofocus. Gallery images are clearer, well-lit, and more consistent with the training dataset. So this behavior is expected in real-world computer vision system and highlights the challenge of real-time image recognition. So in logs, all scans are automatically saved here in logs section, including the image, detected class, confidence, and timestamp. And in the analytics dashboard, it provides total scans, success rate, average confidence, number of detected classes, weekly activity, detection distribution, and class scan trend. So now let's start testing all the classes. First is the bread knife. So the image shows the class res results bread knife with its percentage of accuracy 100%. Now let's scan it again. So it has the same results. Now let's scan using the camera. So as we can see here, the result is bread knife top match 98.2%, or its confidence is 98.2. It shows here in the prediction breakdown the percentage distribution. Now let's move to the next class. So this is the hunting knife. So the app result is accurate. Hunting match with the confidence or accurate 100% accuracy. Let's scan it again. So the result is the same. Then we will try the real-time image. So as what I've said earlier, sometimes the camera ay saan man to. So as what I've said earlier, real-time images are affected by lighting, motion blur, and camera autofocus. That's why the result of this scan is not correct. Now let's move to the next class, karambit knife. So it shows the 100% accuracy. Top class, karambit knife, confidence 100%, classes scene 1. So let's scan it again, the same image. So it shows the same result. Now let's scan it using camera. Now let's proceed to the next class, Kukri. So the detection is correct. It has 100% of accuracy. Let's scan it again. So the result is the same. Now let's scan it using the camera. Now let's move to the next class, the machete. The result is correct. 100% accuracy. Now let's scan it again. So the result is the same. Now let's scan it using camera. So now let's move to the next class, the pocket knife. So the result is correct, 100% of accuracy. Now let's test it again. So the prediction result is the same. Now let's test it using the camera. Next is the santuko knife. So the result is one correct santuko knife with the confidence 100% of accuracy. Now let's scan it again. So the result is the same. Next is the scalpel. It shows 100% of accuracy and correct class name. Next is the boning knife. It also shows the correct class name and has 100% of accuracy. Let's test it again. So the result is the same. Now let's test it using the camera. So now it's the throwing knife. It shows 95.9%. Now let's test it again. So the result is the same. Now, as we can see, the total scans is in analytics. We have 176 total scans, 100% success, average configuration with 95%, classes is 10, weekly activity, detection distribution, and class scan trend. So now we will answer the questions. Question 1. Can you explain how you trained your image classification model in Teachable Machine and what factors influence the accuracy of your model? So the image classification model was trained using Teachable Machine by Google. I created 10 separate classes, each representing a specific knife type. For each class, I collected multiple images with different angles, backgrounds, lighting conditions, and after uploading the images, Teachable Machine automatically trained a convolutional neural network model. So the main factors that influenced the model accuracy were image quality and clarity, balanced number of images per class, visual similarity between classes, and consistency between training images and test images. So after the training, the model was exported as TensorFlow Lite model and integrated into the Flutter application. Question 2. How does your application handle cases where the image confidence score is low and the image does not clearly belong to any class? So when the confidence score is low, the application uses confidence threshold. So if the confidence does not reach the acceptable threshold, the result is marked as low confidence or it shows random class name. So the app avoids forcing an incorrect classification. This approach prevents false positives and ensures the result remains reliable. So additionally, the prediction breakdown still shows all class possibilities so users can understand how the model evaluated the images. This makes the systems transparent and user aware even when the image is unclear. Question 3. How can real-time dashboard help improve decision making or monitoring in real world application of your project? So real-time dashboard provide immediate insights into system performance and user activity. In knife detector, the analysis dashboard helps by monitoring detection success rate, tracking frequently detected knife types, identifying usage patterns through weekly activity, and evaluating overall model confidence. In real-world application, this allows users or administrators to detect performance issues early, improve model training based on trends, make informed decisions using actual usage data, and overall, real-time dashboard transform raw scan data into actionable information.